This one is 3.17. Here there's a carpenter which has a power saw and he's cutting a plank which is 6 meter long, and this plank has a uniform weight, so we can take this as a UDL with an intensity of W naught. Now he wants to cut this plank at a distance of 1.8 meter from the other side, so maybe somewhere here he wants to cut it, and to avoid splitting of the wood he wants this moment at this point should be equals to 0. Now how he is managing that? He is managing that with these two sawhorses. So for one he is keeping it right at the end on this side. For the second one he is able to adjust it so that the moment is going to be 0 at this point. So the question is asking what should be this location D for the second sawhorse. So let's set up this problem and let's draw this beam here. Now the first support that is coming from this one right here is right at the end here. So let's say this is giving us a support R1. The second one here is at a distance D from this side, giving a reaction of R2 there. And this whole thing has this uniformly distributed load which is W naught, and we want to figure out the value of MB and check that this should be 0 here, whereas this distance from here to here is 1.8 meters. If it is 1.8 meters from this side, other side, this is going to be 4.2 meters because your total beam is 6 meters. So let's try to get the value of these reaction forces. So I can draw this equivalent diagram for this. Now right at the center, this W naught times 6 is going to be your equivalent force because of this distributed load. We have R1 here and we have R2 there. This distance is D and this one is 6 minus D. So if I do moment balance about this point R2 right here, I can write down R1 times this distance, which is 6 minus D, will be equals to 6 times W naught, which is this force, times this distance. Now since your UDL equivalent force will be right at the center, so this is going to be 3 meters. So this distance right here will be 3 minus D. So this gives us the value of R1, which is 6 times W naught, D minus 3 divided by D minus 6. Now let's look at this section. So what is happening there? If I draw this beam separately here, in terms of forces, we have this R1 here, and here we'll have a shear force V, and the bending moment right here is given to you as equals to 0. And this distance right here is 4.2 meters. Now if you have a distance of 4.2 meters, this UDL will give you a force value which is equals to 4.2 W naught right at the center. So this distance is 2.1 meters from this side, and this is again 2.1 from the other side. So if I do the moment balance here, I can see that this R1 times 4.2 need to balance moment coming from 4.2 W naught. So this times 2.1 meters. This MB value is equal to 0. So in this case, I took moment about this particular point here. So if I substitute the value of R1, which is 6 W naught D minus 3 divided by D minus 6 times 4.2 on this side, and 4.2 W naught times 2.1. You can see 4.2 cancels, W naught cancels. So now we have an equation in D. So if I solve this, I get 3.9 D equals to 5.4, which gives us the value of D equals to 1.385 meters.